Today's lesson is going to be on comparing fractions. Let's take a look at our problem. Sarah and John are saving $10 for a class trip. Sarah saved 3/6 of the money and John saved 3/5 of the money. Who saved more? Well, the first thing we have to figure out is how can we solve this? And the easiest way to solve a problem involving fractions is to use a model. So I have used a rectangle as the model for the one whole. The whole is the $10 that each of the students is trying to save for the class trip. Sarah has saved 3/6 of that whole. John has saved 3/5 of that whole. Now we're going to see how can we show that using the model we have for the whole. Because we are using a rectangle, this is going to be like what we learned when we learned about fractions of an area. Our one shape is going to be that rectangle. Now we also learned that our denominator is our bottom number in a fraction and our numerator is our top number in a fraction. The denominator represents the whole, or how many parts are all together in the whole. The top number represents just the amount that we're discussing, the fraction that has been saved. So let's take a look of what a model like that could look like. So for Sarah, we want to take that whole and put it into 6 equal parts. Remember, when we're doing fraction of an area, the parts need to be equal. For John, his denominator is 5, so we are going to split that same whole into 5 equal parts. So the size of the whole does not change. It's the exact same shape and size. Just how we've split it up has changed because Sarah has 6 parts to her whole and John has 5 parts to his whole. If we were to shade in what they have saved so far, we know that Sarah has saved 3/6. So we have shaded in 3 of her parts. 1, 2, 3. We know that John has saved 3/5. So again, we're shading in 3 of his parts. 1, 2, 3. Now looking at this, the rectangle is exactly the same size. If you look at the whole on the top here, and you look at Sarah's rectangle, and you look at John's rectangle, all of them are exactly the same size. It's just how we have divided them up. Sarah's is divided into 6 parts because her denominator was a 6, and John has been divided into 5 parts because his denominator was a 5. When we compare these two fractions, we can see that John has actually saved more than Sarah because his goes further. We can see here, there's the line. He has saved more of that whole than Sarah has. That's why we break this to represent it, because it's really difficult to just picture what 3/6 or 3/5 would be, but when we draw a model, we can actually see what it looks like. We can see that even though her denominator or her bottom number is larger, that really doesn't make anything different. That doesn't compare to the fact that he still has saved more money because he has covered more of that whole. So we can create a rule for this. The rule is that when fractions have the same numerator or the same top number, then the fraction with the smaller denominator or bottom number is always greater because we are dividing that same whole into a smaller number of parts. Therefore, those parts are going to be larger. If I have a rectangle and I divide it into 8 parts, obviously the parts will be smaller. If I take that same rectangle and only divide it into 2 parts, the parts will be larger. So it's always the denominator or the bottom number that is the smallest number will be the greater fraction when the numerators are the same. Let's look at another problem. This time we want to know which is greater, 2/4 or 3/4. This time we notice that it's not our numerator or our top number that's the same, but it's our bottom number or our denominator that is the same. We still want to model this problem using a whole. We can use a rectangle again since that's what we used for the first problem. Except this time, because it is the denominator that is the same, we're actually going to be dividing the whole into the same number of parts. Because our denominator is a 4, we are going to divide this whole into 4 parts for both of the fractions. So as you can see, here are our two models. We have 2/4 first, and then we have 3/4. As you can see, 2/4 is less of the rectangle than 3/4. So in this case, 3/4 is greater. It has covered more area over here. We can see here's where it ends. So it has covered a greater area of the rectangle than 2/4. So the rule here would be when fractions have the same denominator or bottom number, then the fraction with the larger numerator or top number is always greater. So in fact, it's opposite from what we just learned with the other fractions we did. So in conclusion, here are the rules that you want to remember. If the denominators are the same, as we see here, we have 2 5s, then it's the fraction with the greater numerator that is going to be greater. And in the second part, if the numerators are the same, that's our top number, these 2's right here, then the fraction with the smaller denominator or bottom number is going to be greater.